Hello, everyone. Cecilia here. Welcome to our second edition of Decoded Road to One. This episode is part 2 of a 3-part series that features technical sessions from OutSystems community members to get you geared up for what's in store at our One conference in October. Of course, in order to attend, you do have to be registered. So make sure that you go right now to one.outsystems.com and get your ticket today. We will have a lot of exciting things in store for you. We have 5 different technical tracks featuring amazing speakers from our community as well as from OutSystems. And you also have the opportunity to get free certification on site. So make sure that you don't miss out on that. We'll also have a lot of activities beyond the sessions. There'll be booths, parties, food. We have a Neo party. We have sponsorship activations where you can engage with them. There's just so much that we have in store for you. So make sure that you check that out. And now is the time to get registered. All right, so now that we're all registered, let's dig into today's speaker. In today's session, we'll be learning about load testing. Load testing is really important from both a business and a technical perspective and ensures that your application is resilient and reliable under high traffic. Our speaker today will cover the key methodologies, metrics, tools, and best practices of implementing load testing within your application. We're joined today by Gonçalo Mota to ensure that your OutSystems app is ready for real-world demands. Welcome to Road to One.
Thank you for having me.
Thank you so much for being here. I'll let you take it away.
Okay, thank you very much. Today we are going to just cover a little bit how we in OutSystems approach load testing. But before that, let me introduce myself. My name is Gonçalo Mota. I'm part of the DevOps team from the Professional Services department at OutSystems. I work at OutSystems around a little bit more than 9 years now. I started as a developer, then moved on to the platform operations expert team, and then later on moved to the DevOps team, where I put together all my experience as a developer and then as well as a platform ops expert. Usually, or nowadays, I've been focused more in load testing. And this is the topic that we are going to cover now. So let's start with an introduction of what load testing is, since sometimes during conversation with people, we tend to talk about different things. So a quick introduction to it, and then we are going to cover very quickly what is the typical methodology that we at OutSystems use to execute load tests. Then we are going to cover a little bit the key metrics that we use to evaluate the results of those tests and extract value from those. Then cover as well the kind of tools that exist in the market, best practices, and as well guidelines to plan and execute and implement tests, load tests. Then we go through a bit of some of the common challenges that we face when implementing load tests, and we have a bit as well of Q&A to the end. So moving on to introducing what load testing is. So the question is, what is load testing? Overall, very succinctly, load test is used to simulate user traffic, in which will be used to evaluate how well our web application or the entire system, how well it performs under a certain specific load. So we are going to increase, we are going to give it a bit of load that will simulate our end users, and with that understand, before it affects our real end users, we'll understand how well does our system handle it. The goal is to determine if, when real world scenario happens, if our system is able to cope with that, as well as in some cases to understand if it can handle some peak times. So for instance, rush sales or some usage of lunchtime that happens in some application scenarios. On a business perspective, load testing helps avoiding costly downtimes. So, for instance, for e-commerce applications, a crash during a sale can result in lost revenue and damage of the brand, and so on. While if we maintain a practice of load testing, we can ensure that performance is stable. So consistent performance will lead to happy customers and greater trust to the brand itself. So on the business perspective, these are the benefits that load testing can bring to the business. And as well on the technical side, load testing help us identify where are the potential bottlenecks that the system has, possible server limitations in terms of infrastructure, or as well possible potential code inefficiencies, if any. So with this, the technical part of it, we can understand, we technical people can understand if the web application it is stable, if it scales properly as the load increases, and with that have proper metrics, proper data that provides us info that the system is stable. Now regarding what a load test is compared with other kind of performance tests. So it is important to differentiate between load testing and the other kind of tests, for instance, like stress testing, spike testing, soak testing, and so on. Here are different names for different things. So load testing is more focused in evaluating the normal operation of our system. So we design the structure in a way that simulates the realistic usage of our applications. And with that, that's what we want to simulate, while other kind of tests usually tend to push the systems to beyond the expected capabilities. So trying to find the weakest link in the system, either at the infrastructure layer or on the code. So it is focused in finding what is the next issue, regardless if that is under the scope of the application use case. These kind of tests usually can be done with the same kind of tools. So a load test tool or a performance test tool, it is able to do load testing, stress testing, and the other kind of tests, which are basically very similar with different configurations and as well with different objectives. So here our focus is in load testing with the purpose of evaluating real use cases, understand if the system handles what is required by the business, instead of just finding where the system can break. Now, cover a little bit the methodology that we use when planning a load test. So first, let us cover a little bit an overview of the process to plan a load test. So generally, this process follows a cycle. Although when we OutSystems provide load testing services, we just end up executing just one window. So we are not going to be inside this cycle. Usually, there are exceptions, but for a company or an organization that has an in-house QA team that executes load tests, this is very similar to other kinds of tests in which there is going to be a phase where there will be some requirement gathering to understand the user behavior, so to understand what the users how they use the application, what is the flow, what is the flow or flows that are used the most, what are the features used the most, and with that collect all that in order for us to design our test plan. Then with having that test plan, we will then start creating the test scenarios, the actual test scripts that will be used by the tool to execute, to generate that load in our system. Here is, depending on the tool, but here is the area where we need to focus more time in building the scripts and having the scripts stable and having the scripts simulating the real usage of our application. Then is the test execution, and then finally collecting all the test results and analyzing those results to then make improvements, take decisions. If the application is okay, move on to production. If not, then we need to understand what happened and fix that. And then again, the whole cycle is repeated. Regarding the methodology itself, here we have the base structure that we use to execute the load test in an application. So we have a set of use cases, one or more, that are focused, that are based on the real scenarios that were identified during the requirements gathering. Those use cases are going to be transformed in test scripts, and then those step scripts are going to be configured usually in incremental steps. So a load test has the structure of first stage is a ramp up, in which we increase the load until our target goal. Then we'll maintain that load. In some scenarios, then the load is decreased as well in a slowly manner, or everything at once. But the main areas are the ramp up phase and the holding the max amount or our target goal phase. During these phases, we have the ramp up, which can be half of the time or 1/3 or 2/3, like the example that we have here of the whole test. But the main idea here, if we follow this approach of having 2/3 of the time in ramp up, we can understand better if there is any issue later on. We can correlate the time of that issue with the amount of users that we have on that moment. So as we increase the amount of concurrency throughout certain period of time, here the steps could be configured, could be blocks of 15 minutes, like we have in the example, but could be as well blocks of 2 seconds, so way more steps throughout the test. But with this, the idea is to understand if there is some issue detected during the test execution, we can then correlate with all layers of the tech stack when that issue happened. If we can find out where the root cause is by directly mapping the data from the database, front-end servers, the code itself, and the load test tool. Then holding the load is mainly for us to understand if the system handles that target and how well handles that target as we maintain that number of concurrent users. One very important thing that is necessary for the test to be as realistic as possible is to have think times. So think times is the concept of think times is the time that an end user takes to interpret the information that he has in front of him. So looking at the web application, and then takes a decision to do some action, interacting with the widget or navigating, clicking in the button, etc. So what we want to avoid is that the load test tool to just start sending the requests in one after the other without time between those, as a real usage of the application takes time due to the fact that the user, for instance, logged in, then it will process the landing page, it will click in another page or in some object, it will interpret information that it has on the web screen, interact with it. So that time between the system respond and then receive a new request, that will be the think time. It is very important to have this in order for the script to have a pace more realistic to a human being, so be more organic. Otherwise, the tool will just send a request, receive a response, and the millisecond after will send the new request right away, which is not realistic. When not sure how much time takes to execute a certain action, a tip is to record someone using the application, and then through that recording, understand how much time on average a human would take to do a certain action. So how much time a human takes between all those actions. Then, as we plan and we are going to execute the load test, later on, we are going to fetch data from all layers of the tech stack. So from the server-side perspective, we are going to collect data either from the infrastructure, front ends and database, as well as from the application layer. And from client side, we are going to leverage the metrics from the load test tool itself. During the test, we are going to monitor the performance of the system to understand if the test seems stable, if the environment crashes, if the test itself, the tool is stable as well, well, regardless of the result of the test itself, because the test might fail its success criteria, but what we want to ensure is that the system, or at least the load test tool, is stable during the test in order for us to properly later on collect data of the test. Now, regarding key metrics to evaluate once we do the load test, there are a lot of metrics depending on the systems that we involve, but the main ones that we collect, crossing all the test data from the tech stack, so data from the database, the server, the front-end server, application layer, infrastructure, and so on. We correlate all that with the load test tool data as well. By default, this is the standard for an OutSystems environment, comprised of the server's database. But in some situations, we might have external APIs and external database connections. So if possible to have that data, it is also, it is good, it is positive to have that data as well to correlate with the performance of our application, because those elements are part of the whole system and can also be the bottleneck of certain performance degradation. The key metrics that we usually focus on are mostly the response, the request response time, the throughput, the error rate, these on the client side or the application layer. Then as well, we correlate the server resource usage, like the CPU, the memory, so the utilization of those resources, both on front end and database levels. And then the application server-side level as well, we correlate with how well did that application handle. We look at the different parts of the code, like the screens, the errors. We collect these data from Service Center or the ODC console, where we see the parts of the code that were used the most and the ones that slowed down the most as well. And with this, we can understand what are the potential bottlenecks here, or we want to understand with the test we want the test to reveal what are the performance bottlenecks and where, either if it is a slow database query or inefficient API, resource depletion on any of the servers, and so on. To collect these metrics on a regular OutSystems environment, we then collect the data from the load test tool when we want the client-side application performance data. Regarding application performance, but server-side, we collect the logs from Service Center or from the ODC console. And infrastructure related depends on the system that we have. For OutSystems Cloud, we can have access to the AWS Cloud Watch of that environment, or if it is an on-prem or self-managed version of the platform, we can either leveraging a monitoring tool, if available, that can provide us those metrics. Otherwise, we can always resort to Windows performance counters, although way more difficult to manage. We have here a little bit more overhead to manage all that in terms of guaranteeing that they are running during the test and that we have all the data needed to process later on. So more difficult, but always a possible solution as a last resort. Now, regarding tools, best practices, and as well some guidelines. So tools are often the main topic that is discussed when we talk about load tests. Nowadays, there are a lot of applications in the market. Several are very, very powerful. Some of them are free and open source. Others have a cost, are proprietary. Some of them also run on the cloud, Others only run on premises, and we have to install those and their agents. But the selection of the tool highly depends on the specific requirements that your organization has, and as well the available resources. So the available budget, and as well the technical people that are able to work with those applications, as some of them are more easier to learn than others. Now, a detail here is that the majority of these tools are, in fact, they work at the protocol level, meaning that once we usually leverage their recording feature, these tools, they record the communication between our web browser and the server side. So with this, they can capture the structure of our use case in the most realistic way possible, but only from the moment in which the browser communicates with the server side. So these tools, or the recording of these tools, act as a man in the middle in order to record those scripts, but they do not cover the client-side code that runs on the browser itself. So that part of the application layer, it is not involved on the tests. So they are going just to replicate the request sent to the server side, and with this multiply for the number of concurrent users that we want to test. With this, well, it lacks here a little bit of visibility of what's happening on the client side in terms when the pop-up is rendered and so on. These kind of widgets and objects that run completely on the client side, on the browser. The tool itself only knows that a specific request was sent, so the tester must know exactly what are the insides of the application being tested, how does that application works, in order to correlate a certain step in the web browser with some request in the tool. And this means that there must be a lot of communication, an open channel between the test team or the tester, whoever is testing, must have a communication channel with the development team. So things must be clear, communication must flow between the team members involved here in order for the creation of the script to be as smooth as possible. So the relationship between what is being done on the use case with the final test script. The tools that work on protocol level also bring more complexity to the script. So there's here a layer in which must be the use case must be then, let's say, translated to the steps in the script is a little bit more complex. And it's also a little bit more complex to learn these kind of tools. On the other side, these tools are more efficient, in fact, compared with UI level testing tools, which have the capability to interact with the UI part of the application. And with that, they have the capability of simplify the developing of the script, but on the other way around, they have an overhead compared with the protocol level tools. And also protocol level tools usually have more capability of scaling when we need to test high amounts with several hundred or several thousand of concurrent users. Nonetheless, nowadays, with the advent of AI, in fact, there are a lot of these tools that now implement some kind of AI algorithms to help the correlation of the objects in the script. Correlation is when is something that is done automatically by the browser, and it's when we interact with the application, we need, as we do steps, we need to correlate the information from the previous step with the new step. Browser takes care of that automatically. The tool, the tester, must work on the script to fetch information that is used on the previous request to add to the new request. That's the part that is a lot. It is very high time consuming. It's too complex or too much. It's very complex to do. So that's why the part of doing a test script can take several days in some cases, when the application new or the use case is new, and with that, depending on the tool, here's where issues can happen with the stability of the script. But nowadays, tools have been improving a lot on that area, especially with AI, to help accelerate the script creation and guarantee that the correlation is stable. So it will actually reproduce the use case that we want to test. Best practices. Well, make sure that, or try to follow these practices when implementing load tests. So the first one is to do the load test as soon as possible in the release cycle of the application, meaning not too close to the actual release. So load test is mainly the last kind of test that we will do. So the application must be stable, must be ready to go to production. What we want to know at this point is, can it handle a high amount of load? So it will be actually the last test to be done, but we want to test it as soon as possible in order to have time to as well fix or adapt, do some changes on the code if needed, code or infrastructure. So whatever changes we need to do, we need to have the time to do those and test those as well. So we want to make sure that we go to production without issues, without concerns. Then we want to test scenarios that are realistic as possible. And with that, we want to be able to correlate those with the business objectives in order to know that once we are going to receive our end users, our business objectives are met with the results of the test. So we can use the test as a prediction tool to understand what will happen in production. So we need to do tests that simulate actual user behavior, and with that collect the metrics that can help us understand what is being impacted on the system, and as well what will be impacted on the end user perspective. So for that, we need to identify KPIs to help us measure and evaluate the success of our application. And here's where we can correlate, for instance, the response times, the throughput, the error rate of the interactions that we have with our application, and with that map those very same criteria or metrics mapped with the success criteria of our tests. As I mentioned previously, it's very important to know, or who is working on the test, to know how is the application implemented and how it solves the business needs, in order to as well understand what the scenarios do, what's the purpose for that specific test scenario, and to understand as well as the tester works on test script, if the test script it is not only stable, but if it is according to the desired behavior that we want to simulate. So we need to guarantee that whatever is done by the script, it is as similar as possible, like an end user would do in the production, in order to have an effective test scenario and be able to diagnose issues during the testing. Always aim for production-like environments. So we can't compare and measure things if we are working on different things, right? So although depending on the costs, this is an issue that is quite frequent, but we should focus and aim to having a test environment for load test purposes as similar as possible to production environment, in order to ensure that we have the right conditions execute this. And as well to compare. So if I launch a certain amount of concurrent users, I want to guarantee that the results of that test it's easily mapped with what can happen in production with those very same amount of users, and avoid doing here some math like well, if we have half of the infrastructure, most probably it can handle the result of half of the load in production is what we can compare to. That is just an extrapolation. So it's not that linear, although we can use extrapolation in some cases when a production-like environment is not possible, but we will try to avoid those situations. And then as well, it is very important to understand what is happening in production at the moment. So it is very important to understand how the system is being used at the moment in production. So collecting data from production environment and understanding how is the current usage, if there are peak usage in certain intervals, and so on, and then use that as a baseline to measure the load test. So it is very important to understand the conditions in which the load test, as production environment is used, and with that understand how the test compares with the real usage in production. In order for us to do then later on make informed decisions based on how the application handle the load during the test. And as I talked about, mentioned the production-like environment. Usually, the environment where these conditions are met usually is a pre-production environment, which is pretty close to production. We would like to shift left this as much as possible, but due to the kind of requirements that the load test has, like having a production-like environment, usually is very difficult to shift these to left. Plus, a load test is something that will be done after the other types of tests. So all the component tests, security, UAT tests, all of those will be already done by now. And our application should be able to go to production at any moment now. It is stable, it is approved. We just want to know if it will handle high amounts of load, or at least a certain target that we expect in production. There's no benefit in running a load test in an application that was not yet, or application version that was not yet approved, that is not completely tested, because if there is some bug, if there is some issue, or some behavior not expected in some of the components of the application, we are going to do a load test, so wasting resources in a test where it won't provide the result that we want, since the application is not ready. So load test is the last thing to be done. But again, although later on in the release cycle, we should do this as soon as possible. So the release cycle itself, if we have an application that is expected to handle high amount of concurrent users, either always or in certain phases of the calendar, we should ensure that the release cycle has time to do proper load testing, fixing, and then again the whole battery of tests, load testing, and not only that, as changes were made. So that's very important to guarantee that if we want to have the best value from load tests in our release cycle, to be able to do all that, like other kind of tests, in the properly manner, with time to execute and evaluate and so on. Some guidelines. So we should simplify the use cases as much as possible. So load testing is not the same as functional testing, or it is not a type of functional test, although when we do a load test with on a high demand application, we might find issues with some with parts of the code due to the high demand, because some parts of the code might not work as expected under high load. But load testing itself is not functional testing. The purpose is to do tests over some flows that are used the most, that the ones that will have a high load of users, and it should not be used to test every object in the application. So the purpose is, like we have in an example, log in, search for a product, select the product, buy the product, and log out. That's it. There might be other functionalities in the application, but there are not functionalities that will be used that much in order to have a load test, and doesn't make sense to add it to this script. This script will be focused in the path, in the flow in which the application is used the most. Another thing is to properly identify the number of concurrent users that we expect to have in our system, or that we already have in production, and then we use that number for our tests. So the concurrent users, or the number of users that we will launch on the test, is different from the number of registered users or the whole universe of users. So what we want to test is actually how much users at the very same time are performing a certain action or a certain group of actions. That doesn't mean that 100 users are at the same time searching for a product, but if we do a test with 100 concurrent users, we'll have 100 concurrent users doing different things of our script, meaning that we have 100 users using our application, and not all the users that we have registered in the application. So we should have these two numbers, and one should be less than the other. Then it is very important to build idempotent flows as much as possible, meaning that we want to aim to have scripts that are stable and as well able to handle changes in the application, unless those changes will actually defer the use case that the script aims to. This is very important, especially if you want to leverage CI/CD pipelines and want to do load test that is leveraged as well by those pipelines. The scripts must be something that are able to, or robust enough to handle fewer changes or some changes in the application. For protocol-based or load test tools that work at the protocol level, this is very hard to do since those scripts are very sensitive to changes on the application. Another thing is to create independent flows, independent from test data as much as possible. The example that I gave above, it is a scenario where it is highly dependent on test data. So right on the beginning, the search for a product step, it is a step in which requires for test data for products to exist in the tool, in the environment that we are doing the test. Otherwise, we won't be able to proceed with the script. In these scenarios, we need to guarantee that all the test data it is implemented in the environment beforehand our test. So it is a requirement of our test for this specific script for a certain amount of test data and a certain type of test data to exist in the system. Since we are talking about business test data, the test data, first, it is very important to be as close as possible or similar as possible the kind of data that the business application will have. So that data should be as realistic as possible, and we should have a lot of that data in order to add variability to the system. This means that we'll have different data objects of the same kind to give here some variability, some difference. So avoiding using the very same test data in all the tests, and even inside the same test through the different iterations. So this way we can avoid having data being cached, in which will impact the remaining of the test and can eventually provide us false positives, and having more more different data of the same type will allow us to have more testing coverage. That variability can be created in a few ways. One of them is actually to randomize a few things in the system to avoid some caching. Here, if it makes sense to the use case being tested, we can also create or having more profiles, meaning different kinds of users with different roles that will work on the same or will follow the same use case. These can mix things a little bit if we have different kinds of profiles using the application. And eventually, if that makes sense, again, we can combine the structure of a load test, for instance, with a spike test in between, meaning two tests at the same time, where the combination of those will match our target. But instead of being just a stable increase, ramp up of users and then maintaining, we can have a spike once in a while if that simulates certain scenarios in the production environment. Here is an example of the very same use case, but in which the data is static. So a specific user will search for a specific product in all iterations of this test user. In order to maintain the load, the same test user can be leveraged several times. So eventually, if the same user searches for the same product, we'll eventually cache this data somewhere in the system, and it will be faster. So it will hinder a little bit the results. It can map a little bit, can mask a little bit some issues that we want to find, as opposed with randomizing for each user selecting a different product. So this doesn't mean that we can have an iteration where the very same user searches for the very same product, but it will reduce a lot that possibility. And here very quickly, just a highlight of differences between the different runtimes of OutSystems platform. So for traditional web applications, one thing that is very important to handle in order to properly do a load test is the view state. Upon the login, we need to guarantee that we fetch the view state on every request or in almost of those requests, but at least for the main requests, we need to fetch the view state and propagate it for the next request. So it's where all the context of the actions done in the application it is where that context is kept, is on the view state. Data variability here is a little bit more easier, is a little bit more straightforward, since we handle the whole request. As for reactive and mobile applications, there is no view state, but there's another token on top of the login, which is the CSRF token. It is a .NET token used to validate the sessions of the users that access the application, that log into the application, and we need to capture this token and as well propagate it throughout the remaining script after the login to guarantee that each test user, every session that is being simulated is unique, and as well it is valid on the server side. So that token is going to be confirmed on server side in order for us to have a properly simulated session. Here we'll have a lot more requests in these kind of applications because we'll have smaller but a lot more requests that's going to be captured on the communication with the server side. So it is a little bit more difficult to work with due to that, as for instance, a single click in the application will be transformed in several steps or several requests. So it's a little bit more difficult to manage. Also, the data variability is a little bit more complex as well due to the fact that one interaction in the application can mean several requests, and some of the data we need to guarantee that is spread out the very same data throughout different requests. So a little bit more difficult to manage. compared with traditional web. Then for ODC applications, also very similar to reactive, but for the login, that is the SRP protocol that must be handled. So there is a specific flow that must be built to take care of that protocol. And since the protocol expires, or the token of that protocol expires, a request to refresh that token must be done between certain requests throughout the test in order to guarantee that the session is active. Now, let's cover very quickly some common challenges during the preparation and execution of load tests. So one is that during the preparation of the test script, which is very difficult, and as well the actual execution of the load test, there should be no publishes on that specific environment. So we are testing a specific version of the application that was published on that environment, and it's against that version that we are going to test or do our load test. Another one is that we should always use the very same number of test users for the number of concurrent sessions that we want to simulate. Always avoid using the very same session multiplying, or the very same user or set of credentials multiplying for different concurrent sessions. That will not provide a successful, or at least a realistic scenario, since that doesn't happen in reality, and can also uncover issues. Well, not uncover, but it will bring out issues that won't happen in production, and they might be probably related to caching and as well breaking the sessions of those users, as these users are launching at different times of the test, and one user might have done the login while other is doing the logout. So different sessions will impact each other, and that will just affect the whole test. Another thing is when there is no network access between the load test tool and the environment that we want to test, and sometimes a VPN is built in the middle to connect those. Here the issue is the potential bandwidth of the VPN. So could be a limitation. The majority of times it is a limitation, depending on the amount of concurrent users that we want to simulate. Another is the single sign-on functionalities in the applications. Although most of the times we want to test as well how well will the single sign-on handle that much concurrency, but the majority of times for testing purposes is very difficult to set up the test users with single sign-on, or the component of the single sign-on is not ready for production like size in the test environment. So majority of times we end up by bypassing this component. And then any multi-factor authentication implementation or functionality that we might have in our application must be bypassed as well, due to the fact that the purpose is security and we are doing a load test with the machine, right? So the tool will not be able to do the second stage, or more than second, so won't be able to do the other stages of the authentication. So we must bypass this in order for the tool to generate the load, because the purpose is just to test load and not test the functionality. And then as well, to know beforehand if any API, any integration that the application has that is going to be involved in the use case to be tested, if they are ready to the amount of load that we want to test. In some cases, an integration in the pre-production environment or in a test environment, it is not ready to handle the load that we are aiming to in our application, and that makes that integration the obvious bottleneck at the moment. And with that, we cannot uncover possible issues or other bottlenecks in our application before going to production. So it is very important to know if all the integrations that are involved, either APIs or external databases, that are being called in our load test environment, either pre-production or other, if they have the necessary requirements or if they are ready to to receive that goal, that expected load that we are aiming to. And that's it.
Thank you so much for that very interesting talk on really a very important topic. You know, performance is something that maybe developers don't always think about, but can really impact the user experience. So really appreciate your insights. Yeah, I do have some questions for you. The first is, you mentioned, you know, identifying the concurrent number of users when doing your testing. How do you actually determine the number of users to simulate in a load test?
Well, if we can collect that from production environment, the better. So from that moment, we can understand what's already being used in the production environment, and from that moment onwards, we can already prepare for that amount of users and do load tests based on that. Otherwise, we will need to extrapolate a little bit on some behaviors. For instance, if we have, again, an e-commerce application, and then we have rush sales, Black Friday, and so on, if there are some patterns associated, patterns in terms of accessing our application that are associated with some marketing campaign, we can try to leverage here some math to extrapolate and understand how can we achieve that number. But the majority of times is just comparing and evaluating what is the real usage in production, and then just guarantee that our tests cover that amount, maybe with a little bit more
yeah, that makes sense. To always try and use that real world data if available. So, and then once you've identified that there are performance issues, how do you determine if it's an infrastructure issue or a code issue that's causing the problem?
Okay. So we will need to correlate data from all the layers of the tech stack. So that's why it's very important to set up the test itself. Then we are going to grab information from that specific time in which the test occurred, and we are going to correlate with the data from the database, the front-end servers, the logs from Service Center regarding the code itself, and we are going to understand the behavior as well of what the load test tool perceived in terms of if the request response times increase or not. So we are going to correlate all that, and if on the tool side we have a spike in response time that, well, identifies that something happened there, so the experience of the end user would not be good for some reason on that point, we are going to compare with all the other metrics. And with this, what we want to understand is from which metrics, which one was the first, and which ones are tied to each other in order to find out the root cause. If it is infrastructure related, for instance, the resources maxed out, so resource depletion. If on that specific moment where the issue happened, if we have a near 100% CPU of the front end, then we know that's an issue there. So that's regarding infrastructure. But if infrastructure seems okay, but then we have slow times, probably was something with the code, and we are going to drill down on that. And we might find out some query being involved there, calls to the APIs, and then we are going to drill down and find out if the API server, the external one, if we have that option, we are going to understand if was that the one that slowed down, and with that, understand what was the root cause. So we need to put everything on top of the table, and then starting to separate things as we evaluate.
Yeah, like putting all the puzzle pieces together and
right.
kind of drawing the conclusions from there. Yeah, absolutely. Well, again, thank you so much for being here and for sharing your insights. It was really great, and yeah, we're excited to learn more at ONE. So,
okay, thank you very much.
All right, well, that's it for our second episode of Decoded Road to ONE. Make sure to subscribe to our YouTube channel to see our next and final Road to ONE episode, which is Embracing ODC for Future-Proof Development, a Journey Through Adoption and Migration. Thanks for joining us, and we'll see you next time.